Hi, my name is Fahad bin Fadil Azmi and my matrix number is 01 DEE25F1137. So what is diode? A diode is a device that allows current to flow in one direction. It is widely used in the electrical circuit, especially in rectifier and a clipper circuit. So in this video, we're going to use a bridge rectifier. So bridge rectifier is a circuit that converts AC alternating current into a DC direct current using only 4 diodes. So as you can see, this is our setup to make a bridge rectifier. The 4 diodes will put it like a square, and then there is a resistor which using 3.3 kilo ohms. But as you can see, and you can also see that the connection, there's a clipper, a red clipper and a black clipper, which is connected to oscilloscope and a power supply. So that if you cannot see it properly, I have put it a drawing circuit so that you can actually understand it. But so this is the tools that we use to make a bridge rectifier. So first we have oscilloscope. It used to see the waveform of the voltage in the circuit. It can observe the AC, DC input and or output in the waveform. Next thing is a function generator, is to produce the AC input signal for the bridge rectifier circuit. And thirdly is the power supply, which is important. It provides adjustable direct current DC voltage to power electronic circuit during the experiment. So these are the things that we use to connect in our breadboard in order to make a bridge rectifier. So one of the things is the diode, which we call the black one is 1N4007 diode, which is to convert AC to DC in power supply circuit. Next thing is 3.3 kilo ohm resistor. It used to as a load resistor, so that it allows the current to flow. So rectifier circuit explanation. So in bridge rectifier, it has two, which is positive half cycle and negative half cycle. For positive half cycle of the input voltage cycle, M is positive and N is negative. DE1 and DE3 in this image are forward bias, and DE2 and DE4 are reverse bias. Current flows from point M to E, then it goes to D1, it comes to A, to RL, then to B, then it flows to C, D3, F, and finally N. A positive wave cycle will result at R load. As for the negative half cycle, negative half cycle of the input voltage cycle, M is negative and N is positive, which is different from the positive half cycle. Then the D2 and the D4 are forward bias, and D3 and D1 are reverse bias. So the current flows from the point N to F to D2, A, RL, B, C, D4, E, and finally to M. A positive cycle will result at R load. So how diode allow current to flow in one direction? So the p-type semiconductor contains many holes which act as a positive charge carriers. The n-type semiconductor contains many free electrons which act as a negative charge carriers. When these two materials are joined together, they form a p-n junction. At the junction, electrons from the n-type region and holes from the p-type region combine with each other. This process creates a small region called the depletion region, which acts as a barrier that prevents current from flowing freely. When the voltage is applied to the diode in the correct direction, known as a forward bias, the position terminal of the power supply is connected to the p-type side and the negative terminal is connected to the n-type side. This external voltage reduces the barrier in the depletion region. As a result, electrons from the n side and holes from the p side are able to move across the junction. Because the charge carriers can move freely, electric current flows through the diode. However, when the voltage is applied in the opposite direction, known as a reverse bias. The positive terminal is connected to the N-type side and the negative terminal is connected to the P-type side. In this condition, the depletion region becomes wider and the barrier becomes stronger. The charges carriers cannot cross the junction, so almost no current flow to the diode. Because a diode conducts electricity during a forward bias but blocks electricity during reverse bias. It allows current to flow in one direction. This characteristic makes diode very important in many electronic circuits, especially rectifier circuits, where they are used to convert alternating current AC into directing current DC. After we assemble our bridge rectifier and connect it to the power supply and to the oscilloscope, we should get two waveforms. First, we got the half waveform from the top, and the second, we are going to get a full waveform like this. In conclusion, the experiment demonstrates how a bridge rectifier converts alternating current AC into direct current DC by using 4 diodes arranged in the bridge configuration. The diodes allow current to flow in one direction through the load, even though the polarity of the AC supply changes during each half cycle. As a result, both the positive and the negative half cycle of the AC input are utilized, producing a full wave rectifier output.